Why do you feel as if you're about to be thrown backwards off a roundabout?
And why do you keep going round?
When something is being swung in a constant circle, for example, this bucket of water,
You would expect the water to fall out due to gravitational force.
but when it's swung in a constant circle, the water does not fall out.
This is because the water wants to go in a tangent to the circle, and therefore becomes helplessly wedged in the bucket.
This is why, when you swing your mum shopping in a circle, you aren't covered in flour, and your mum doesn't receive a baton burst to the face.
I don't think your mum would mind that.
Harsh. But currently, we have the filling of the physics pie. But not the pastry. This means that it is sloppy and does not hold together properly.
And the pastry is, drum roll please, centripetal force.
Bit of an anticlimax, I know. But nevertheless, I think you'll find it moderately interesting at least.
When something is being swung in a constant circle, its velocity changes even if its speed stays constant, as its direction is constantly changing.
This means that it is accelerating, and it means there must be a resultant force acting on it.
This force is the centripetal force, which acts towards the centre of the circle, like acceleration.
Centripetal force is a force requirement. Any force can act as one, such as gravitational or frictional.
But how does this truly riveting information relate to roundabouts?
How?
The centripetal force keeping a person on a spinning roundabout is provided by the friction between their shoes and the floor of the roundabout.
If this person were to jump vertically upwards, the friction would disappear, and they would continue moving off at a tangent to the roundabout, eventually falling off.
Another question you may ask is why you feel flung outwards when we have just told you that the only resultant force is centripetal force pulling you inwards.
Why?
This is simply due to the fact the person really wants to travel off in a straight line, but is constantly pulled around in a circle by that frictional force.
Rather like the helpless water in the spinning bucket.
So there you have it.
The physics of roundabouts.